Hello and welcome to part 4 of the chapter Triangles. Today we are going to see the third theorem, very famous theorem, Pythagoras theorem. You must have learned Pythagoras theorem in standard 7th or standard 8th and also in standard 9th. But for the first time, we are going to prove this theorem. You know the statement of the theorem. In a right triangle, the square of the hypotenuse is equal to sum of the squares of the other two sides. We'll look at the figure. In triangle ABC, angle B is a right angle and BD is drawn, which is perpendicular to AC. Let's see what is given. In triangle ABC, angle B is equal to 90. BD is perpendicular to AC. And what we are asked to prove is AB square plus BC square is equal to AC square. Now, in this figure, there are three triangles. And what is very important is, while naming these three triangles, you should know one-to-one correspondence between their vertices. For example, so triangle ABC. And when we name the triangle, say ABD, how to name it? See, ABC. A is a common vertex, so we have to start with A, then come to D because it is a right angle which corresponds to angle B of triangle ABC, and then B, A, D, B. In the same way, while naming the other triangle, we should start with B, then come to D, and then C because their C is a common angle. Why this correspondence is very, very important, I'll explain. To start this proof, you see, we want AB square. To get AB square, we want two triangles with AB as a common side. Let's see. Yes. Triangle ABC and triangle ADB. See how the naming of the triangle, very, very important. Start with A, is a common angle. Then go to the right angle, that is B. In this triangle it is D, and then the third vertex. And these two triangles have AB as the common side. So angle A is equal to angle A because it's a common angle. Angle ABC is equal to angle ADB. Each is a right angle. So the two triangles are similar by AA criterion. Now we want AB square. So we take AB from the first triangle. AB, corresponding side of AB in the second triangle is AD. See, AB and then we get AD. When we go to the from the second triangle, denominator you write first as AB because we want AB square. If you look at the AB from the second triangle, then you get here AC. So we get AB upon AD is equal to AC upon AB. Therefore, AB square is equal to AD into AC. This is the first part of this theorem. Remember the correspondence. So then writing the steps become very, very simple. Now, see, second we want BC square. So same way we'll consider triangle ABC and BDC. Yes. I have continued written this fifth statement again here for continuity. Now A, B, C and B, D, C. Here C is a common angle, and again there is a right angle. Each is a right angle is there, angle ABC and angle CDB. So again by AA similarity criterion, the two triangles are similar. Then this time the two triangles have BC as a common side. So BC from the first triangle corresponds to DC from the second triangle. Since I want BC square, I am taking BC from the second triangle in the denominator, which corresponds to AC from the first triangle. So you get BC square is equal to DC into AC. Now, if you look at the right hand side, left hand side of what is asked to prove is AB square plus BC square is there on the left hand side, and our statement 5 is AB square and statement 10 is BC square. So add both. So when you add both, on the right hand side you will get AD into AC plus DC into AC. AC is common. So what you get into bracket is AD plus DC. Look at the figure. What is AD plus DC is AC. So it becomes AC into AC, which is AC square, and thus we get the final result AB square plus BC square is equal to AC square. Now you will say there are 14 steps in this theorem, so it is the most difficult theorem. No. First of all, the two steps can be reduced. If you want, sixth and seventh statement is not compulsory. You can say similarly, triangle ABC is similar to triangle BDC. Directly you can write that. You can avoid sixth and seventh statement. But eighth and ninth is very much required. This is one thing. Then again, even if there are say 12 steps or even if say 14 steps, so let's go ahead with the 14 steps. 10 steps, 5 steps, first 5 steps and the second 5 steps are exactly similar. That is, they have a common angle, each is a right angle, AA similarity criterion, corresponding sides of similar triangle, and so on. So it is not very, very difficult to remember this, remember the concept. Once again, I will explain you the entire theorem. Yes, here is the entire theorem. Let us look at the first 5 steps. We select two triangles ABC and ADB with AB as a common side so that we get AB square. There is a common angle A. Each is a right angle is there. Therefore, the two triangles are similar by AA similarity criterion. And then we want AB square. So AB upon AD is equal to AC upon AB. So you get AB square is equal to AD into AC. In the same manner, select two triangles with BC as the common side, and they are triangle ABC and triangle BDC. Look at from 6th to 10th. It is exactly similar. A common angle, a right angle, AA criterion, and here BC is the common side. So you get BC upon DC is equal to AC upon BC. So BC square is equal to DC into AC. Just add statement 5 and statement 5 and from statement 10. Okay, so I think here it is, there is some, it is from statement 5 and from statement 10, not 4 and 9. Then we get from statement 11, we get the just AC is the common, and then what is inside the bracket? We are adding the two segments, so AD plus DC. We get AC into AC is equal to AC square. Just one slide correction. You can copy from this slide, but please do a correction in statement number 11. The reason is not 4 and 9, but it is 5 and 10. 5 and 10. That's all for today. See you again with the last theorem from this chapter. Thank you.